Hi, in this video we're going to be looking at using the inherently parallelized functionality of several AFNI programs, which means that if you have multiple CPUs on your computer, these programs can be run using that increased power and therefore running faster and potentially more efficiently. So let's take a look here. I made a list earlier of the programs in AFNI that are compiled with this parallelized functionality. So a lot of the programs are written with what's called OpenMP, which is a library for parallelized message passing. And if I show this list here, you can see that there's a lot of programs that deal with warping that use it. So 3D Alineate, these are nonlinear warping calculation programs, and 3D Warp itself, which is the main nonlinear program, a nonlinear alignment program. This is an exceptionally useful one to make sure that you're using the parallelized functionality on. AlphaSim, or the more modern 3D ClusSim, is also another important one to really just save yourself time. But as you can see, there's a lot of programs here that that benefit from using multiple CPUs. In fact, in this list, there are 39 programs at the moment, and this number is always possible to increase with different programs and that. So anyways, there's a lot of functionality that we can make use of this inherently parallelized capability. So now we want to know, well, how many CPUs do I have available on my computer? And the best way to check that is I could run the AFNI system check minus check all, and when it finishes running, up at the top is actually the information somewhere here. Yes, number of CPUs. So I can see here that on my computer there are 8. Probably a better way to get this information would be to run the same system check, but pipe this through a regular expression program called grep. So this will find the line from this text that contains CPU in it. So this is a slightly faster way, and it doesn't involve me, because it doesn't involve me scrolling back up through the text to find it. Okay, so that's just a shortcut to find this information. I could also go to my system details. That's fine as well. But if you have AFNI installed, now we know the answer. Okay, so how do I find out how many CPUs are being used right now? And then how can I control it using an environment variable? Well, the easiest way to find out how many CPUs are being used by a program is, what I like to do is run the 3D warp help with the -hview. So this will open up the help in a text file. And if you notice, something that it did is it displayed in my terminal here the OpenMP thread count. So this means that this is the number of CPUs that the program is set to use currently on this operating system. So by default, with nothing else being set, it's set to use all 8 of my CPUs. Okay, now this may be good because this is the most amount of CPUs it could use on my computer at this time, but I may want to set it to less, or if it's set to something different, I may want to set it to more. Okay, so let's explore how to control this. There's an environment variable called OMPNUMTHREADS that we can set. Now first, where do I set it? I want to find out what kind of shell I'm using. So if I type echo $0, it will show me that I'm using the bash shell. So this determines some of the style of syntax commands if I want to define a variable or something like that on my operating system. You may have Tshell. You may have something with minus, like -bash or -tcsh. The minus doesn't affect this. That just means it's the login shell. So in my case, it's bash. That means that I want to open a file on my computer called .bashrc. So this is where I can set what are called runtime commands for my bash shell. So I'm going to open this up now. Again, AFNI open -e we've used in other videos. This just means that this program in AFNI will find a text editor to open this file. So if you know the name of a text editor on your program, on your own computer, you can replace that with it. Okay, so here we are in .bashrc. There may or may not be, depending on your operating system, things there already. I'm just going to go down to the bottom of my .bashrc, and just so we're not distracted, I'll go here to this empty spot. And what I'm going to do is set an environment variable. Now I had to know this .bashrc, I had to find out what shell I'm using, which determines the specific file that I set and the style with which I set it. So here I'm going to say export. This variable is called OMPNUMTHREADS. And I'm going to set it equal to a number. Here I'll set it equal to, I don't know, 6. Okay, so this is, again, in this file in my home directory. This means home and then .bashrc, and you should have a file here set up already if you followed the install instructions. So now I'm going to save this file and I'm going to close it. Okay, now at the moment I've made this change in this text file, but my shell, my terminal here, doesn't know about it because the shell, the terminal, just looked at this file when it opened, and it won't look at it again until I either tell it to, and then it could read in any new variables or settings there, or if I open a new terminal. So to tell this terminal to look at the file again, I can say source this file. Okay, and I'll hit enter. Fine, and you can ignore this message. That's just telling me that I closed that text file. Okay, now if I type 3D qwarp minus hview again, let's see here. The terminal message tells me that omp thread count is set to 6, which is just what I had set it to. Okay, and I can also see now in the terminal that if I have echo, if I put a $, which is the syntax for starting the name of a variable, and I can start typing this OMPNUMTHREADS, and I can hit tab even to autocomplete, and I see that it recognizes in the terminal that this variable has been set, and the value is 6. That export in my .bashrc means that the variable is set in that script and exported to the terminal using it. So now here in the terminal, this variable is set, 3D qwarp is recognizing that, and basically all AFNI programs should be recognizing it. For those of you who are eagle-eyed, you may have noticed that here in my 3D qwarp, the help file, the OMPNUMTHREADS variable, the same message that's here is also set here, and this still says 8. The reason this says 8 is because this text file, this help file, was created by running the app search command. And when this file was created, my OpenMP variable number was set to be 8. So this text file is not being made again, it's using the one that was originally made. So this value is basically out of date now. So if you do this, you might see a value here. The correct value and the one that's being used is this more dynamically read one here, which is 6. Okay, so that's fine. So this OMPNUMTHREADS is what's called an environment variable that we've set, and now my terminal knows about this. So if I ran 3D qwarp, this is how many CPUs it would be using. Okay. The same thing if let's say I was in a Tshell. Let me switch here, and now if I type echo $0, I see that I am in fact in a Tshell. At the moment, if I type 3D qwarp, it's hview, it's actually also going to be using 6 because this value is passed along from when I started in my bash shell. If I wanted to set this variable, as you hear the police going by my window, if you wanted to set this variable for Tshell, you would set it in the equivalent text file for the Tshell shell, which is .cshrc. And here you can see I have a little bit here from my AFNI setup. Here I could say set env, and the name of the variable is OMPNUMTHREADS, and let me set it to 5. So if you notice, instead of export, I'm using this set env, and instead of an equal sign here, it's a blank. So this is basically for most intents and purposes, the main difference between Bash and Tshell as a user is the syntax for setting variables like this. So now if I source that file, 3dqwarp minus hview, I see that now in my Tshell that value is superseding the .bashrc one that I set earlier. Okay, and if I exit out of this and back in my bash terminal now, if I type 3dqwarp minus hview, it is reading the one from the bashrc, so it's set to 6. Now, in reality, I wouldn't have these set as separate things on my own operating system. I would just set it once in my .bashrc and let it go from there. So let me just, I was just showing that as an example of how to set it for people who are using Tshell as their login shell. This is what you would have. Okay, I'm going to comment it out now in this file because I'll just inherit it from the .bashrc. Now, if you're scripting, what you can do is you can set this variable also in your script. So let me just start a new text file. Oh, and maybe I should mention, if your variable doesn't appear to be set, you really want to make sure that you're spelling it correctly. I'll show it here. It's very easy to make a typo when spelling this. And also to make sure that you resourced your .bashrc file, or if you open a new terminal, you should still, oops, there I spelled it wrong, and set this variable, then it should be here. So if you did not have the new value of OMPNUMTHREADS come through, and if your 3dqwarp minus hview didn't show the correct value, then those two things. First of all, make sure that you're setting it in the correct file for your shell. And again, you can check your shell like that. And make sure that you spelled the variable correctly. To set it in a program, let's say you have a Tshell script that you want to make, for example. So I'll say AFNI open -e do 00 run.tshell. Okay, so I'm just going to quickly set Tshell up there, and I can do the same thing that I would do before in the .cshrc. So again, this Tshell syntax will determine what I'm setting here. So I'm going to set OMPNUMTHREADS, and I'll just make it 3 here to be something different from before. And in this script, I'm just going to run 3dqwarp minus hview. Okay. So now I've saved this script. So when this script runs, each line will get executed. And if, just pretend this it was a more real command, but you can see whether or not this variable is being set here. So now if I type tshell do 00, there, you can see that indeed in the terminal here, the new value is being readed. So I've run it successfully. And again, this is still the stale value from before. Now, something to note, in Tshell, you may be wondering, why didn't I just use the set syntax? Normally when we define a variable here, I might say set variable equals, I don't know, some number. The difference between set and setenv is if this script calls a command with a subshell, so let's say I use this script to call another Tshell script, this value would be passed along, but this one wouldn't, because I'm setting an environment variable here. This variable will only exist in this script. This one would be passed along. So if I, let's say, made my script something like this, now I said tshell do next.tshell, and let me make this script here. So if in this script I say 3dqwarp minus hview, okay, so this is a Tshell script that's only going to call this, and if you notice here, this script I've commented out running. Well, here, let me just, well, I've commented it out, so this one will be run. I'll delete it just so there's no confusion here. Okay. Now, if I call this script directly, what will be the value of 3D keyword, the OMPNUMTHREADS here? So if I type tshell do next directly, what is the value of the number of threads that should be being used? Well, where is it going to come from? It's going to inherit from the terminal. So what would it be in the terminal? It should be 6, OMPNUMTHREAD of 6, right? And verify that. There it is. And remember, in my Tshell, if I had run it here, this is also 6 because I commented it out in my Tshell script. Okay, so I set it here now. So if I just type tshell do next, indeed, the number of threads is 6. Okay, now what happens if I run this by running do 0, 0? So this program sets this variable and then it calls this tshell do 0, 0 run. If you notice here, the value of OMPNUMTHREADS is 3. Because this script got run, it set this environment variable and then passed that along to do next. What if instead of setting the environment variable like this, I just said set env, or set that, and I set a variable OMPNUMTHREADS like this? Well, if I tshell do 0, 0, indeed, just running that program directly, there it's set equal to 6. Right, so what happened here, this number here, if you notice, does not match here because this was just set for only in this script and it wasn't passed along to this subshell. So when this script started running, it didn't get the information that this environment variable should be set. If instead I set env like this and run the program, there you see now it's passed along. So that's just an example of the difference between set and set env if you're running a script. Okay, and here in this scripts directory here, I have a couple examples. If you're running a bash script, it's similar to what you might expect from how we set the environment variable in the .bashrc. Here, I just say export OMPNUMTHREADS equal, and there. So let's say now I bash and run this script. And indeed, with that style of exporting here, this variable is recognized in this script, and it would be passed along to subshells as well, so other scripts that might be called. Okay, and then fine. And something I'll just note for people who are using clusters, for example, at NIH, we have a BioWolf cluster, which is very nice to use. You can set your OMPNUMTHREADS to be the same number as the number of CPUs that you're using for your SBatch or your Slurm usage. So I wrote that syntax here in this script. I'm not on the BioWolf cluster at this moment, so I won't run this. But if you have a Tshell script, what you can do is you can say if this variable is set, and this variable will be set if you run, if you submit your process to be run in what's called the Slurm mode or SBatch on BioWolf, then you can say if this variable is set, that's what the syntax means in Tshell, then set your environment variable like this. And the else case here is inherently do nothing, so just take the value that would be passed along. If I wanted to, I could say else and then set it, I don't know. Hopefully I wouldn't have to set it to be 1, but this might be something I could do, or some other value. I don't know how I would know this, that's up to you. But this syntax is really nice if you're running on a cluster. And the only thing here that would change is if you're running a bash script instead of Tshell, you just have to adjust your syntax for an if condition to be the bash if condition, and instead of set env, it would be export OMPNUMTHREADS equal to that variable value. So that's just something for BioWolf users or general cluster users. Okay, there you go. Hope that's useful.